In the early 19th century, a British schoolteacher named John Dalton was hard at work, pursuing his fascination with chemistry, which would lead to our next great discovery. Dalton's experiments showed that the known elements such as oxygen, hydrogen, and carbon combined in definite and constant proportions. From his calculations, he hypothesized that the elements must be made up of smaller, invisible pieces of matter with relative and distinctive weights. He called these pieces of matter atoms. So, what did Dalton discover?
Dalton's great discovery was what he called the relative weights of ultimate particles.
Ultimate particles.
That's what he called it. It's a lovely phrase. Later on, when he went public, it becomes atomic weights, and we know it as atomic weights, but it was ultimate particles.
So he used the word atoms.
He used the word atoms. The idea of an atom, of course, goes back to Democritus. The problem is, it's an idea. Is it any use? And Dalton was the man who made the idea useful. That was his great contribution.
From his work, Dalton developed what came to be known as his atomic theory, a revolutionary new system that defined the relationship between atoms and the elements.
And it's an enormously simple system, and Dalton thinks very simply, very visually. Here are the elements, here are the weight of the elements, here are the complex molecules, and it's a wonderfully effective system. It connects the thing that chemists can do, weigh things in balances, with the things that you can't see, the ultimate world of atoms. That's genius.
How important was Dalton's discovery? His atomic theory helped generations